Let's look at how we can find the final velocity of an object if we know its initial velocity, the acceleration, and the time that it's accelerated for. So in this case, we're trying to find out what v is, the final velocity. If it starts out with an acceleration, let's give an example of 10 meters per second, and it accelerates at 2 meters per second squared for a time of 6 seconds. Now, that acceleration of 2 meters per second squared means its velocity increases by 2 every single second. So to work out how much it increases by in total, we just multiply the acceleration by the time. So in this case, we're going to multiply the 2 times 6. So the total increase in velocity is going to be 12 meters per second. However, it had a velocity to begin with, so we must add that to our increase to find out the final velocity. So what we find out is we get an equation that we can use for this, which gives an answer of 22 meters per second. Okay, so this equation here, v equals u plus at, can be used to find the final velocity, but we can also rearrange that equation to find things like u or a or t if we have the other three things. This equation also works for decelerations. We just have to remember that a must be negative in that case. Let's look at how we can find the acceleration of the object if we know the final velocity, the initial velocity, and the time. So let's give an example where we're trying to find what the acceleration is, but we know that v is 30 meters per second, the final velocity. If it's initially traveling at 10 meters per second, and the time that takes is 4 seconds. Now, acceleration is just the change of velocity per unit time, so really how much faster it gets each second. But to work that out, the first thing we need to do is we need to find out how much faster it gets. So in this case, we take v and we subtract u. That will tell us how much faster it got across the whole of the 4 seconds, but we want to find out how much it got faster in just 1 second, so we have to divide that by the time afterwards. So our equation for acceleration is v minus u all divided by t. So if we see how that works for this case, we have that the acceleration will be the final velocity, 30, minus the initial velocity, 10, divided by 4. Now, 30 minus 10 is 20, and you can see that top line just gives us how much faster it's gone. It's gone from 10 up to 30, so it's increased its velocity by 20, but it did that in 4 seconds, so we divide it by the 4, and that gives us that each second it increases velocity by 5, and it's an acceleration, so it's meters per second squared. This equation also works for decelerations, but the number should come out as a negative to show that. Key thing to remember in that case is, remember that v is the final velocity and u is the initial velocity. Make sure they're in that order. Don't just put v in as being the biggest velocity. You need to make sure that it is the final velocity. We have 2 equations that deal with acceleration. So the first one gives us the acceleration if we know the final velocity, the initial velocity, and the time. The second one gives us the final velocity if we know the initial velocity, the acceleration, and the time. These may look like 2 different equations, but they're actually exactly the same. So if we take the equation on the right hand side here and subtract u from both sides, or bring u over to the other side of the equal sign, we end up with this equation. If we divide both sides by t, we get v minus u divided by t is equal to a. So you can see that's exactly the same as our other equation. So we can actually use either of these equations in cases where we're dealing with accelerations. I would say it's easier to use this equation in all questions except for ones where it's a that you're trying to find out. So if I'm asked to find out v or u or t, I would use this one. If I'm asked to find a, I would use this one.